All right, so we're on to the next topic. This is angles in a circle. And start off with, we're going to see what happens when we form an isosceles triangle within a circle. All right, so to start off with, one of the terms that you need to get used to is if I have a line going across like this, so it's not necessarily going through the center, but it could also go through center. This is what we call a chord. So if I have a straight line going from one side to the other, I call that a chord. Then if I was to join up the ends of the chord to the center of my circle, because both of those lines there, both of them are going to be my radius. And essentially that helps form an isosceles triangle in a circle. And because they're both my radius, that means these two angles at the bottom here are going to be the exact same. And we'll use this fact to help us find out the missing angles in some circles. So the key thing is, when I've got a triangle where one of my points is at the center of the circle, because I've got those two lines which are my radius, it makes an isosceles triangle. So let's look at some examples using that then. So all this is asking is find all the missing angles. So to start off with, here I've got my isosceles triangle, and that means this angle here and this angle here are going to be the exact same. So that is also going to be 35 degrees. And so this angle here, going to add up my two 35s together, which gives me 70. And then I'll do 180, because remember, 180 degrees in a triangle. Take away the amount I do know, and that means that's going to be 110 degrees in there. Okay, so on to question 2. So again, it's this angle here and this angle here that are going to be the same. So I need to figure out how many degrees are left. So I do 180, take away the 80, which gives me 100. So between this angle and this angle, the total is 100. And I divide that by 2 to give me 50 degrees. But I also have this little bit that's out here. And remember, angles on a straight line like so add up to 180. So that means this bit here is going to be 100 degrees. Okay. So question 3 then. So here I've got something a bit more interesting. Now the key thing is that this line is dead straight, as is this line, which means what I've got here is an X angle. And if you recall, X angles are the exact same. So I need to work my way to find out what that middle angle is. So to start off with, this angle here and this angle here are going to be identical. So that's also 44 degrees. And to find out that last angle, add up what I do have. So 44 add 44, that's 88. Take it away, that's going to be 92 degrees. So in there is 92 degrees. That means the opposite side, since it's an X angle, is 92. And in fact, actually, it just means that triangle is identical. All right, and then the last one then. So I want to find out essentially what these angles here are for this question. So I want to find out what that angle is. Now the key way to deal with one of these questions is if I look at just one of these segments, I've got my chord and I've got my radius and my radius. So I've got my isosceles triangles. Now what I need to do is I just need to figure out what one of my angles is. And the key thing is to focus on the center. If we recall, angles in a center, angles in a circle all add up to 360 degrees. So I just need to find out this little snippet. So all I need to do to figure out what just one little bit here is I take my 360 and I divide it by 5. So I'm going to do 360 divided by 5, and that's going to give me, carry my calculator, 72 degrees. And so then I need to figure out what just one bit down here is going to be. So I've got to firstly do 180, take away the 72 to find out what is left. And when I do that, that's going to give me 108 degrees. And recall, this bit here and this bit here are going to be the same. So I've got to split the 108 degrees up. So I divide it by 2, which gives me 54 degrees in each of those little bits. And that means the bit on the other side is also going to be 54 because they're identical. So that whole angle here is going to be, so this whole angle all the way around, that's going to be 108 degrees. So there's lots of different ways we can go about approaching this, but the idea is the moment you can see that isosceles triangle, then make sure you're using use of the rules of the fact that the two angles are identical. Let me know if you have any questions, and good luck with the work.